Hi all, this video is about clustering with images. So we're gonna load images using PyTorch data loader, which prepares them for processing in batches. So we are gonna use transforms. Therefore, the compose function applies transformation to images such as resizing to 224 cross 224 pixels, which are suitable for models like clip, and converting them to tensors. So this PyTorch utility loads images from directory structures and apply transformations. So coming to data loader, which combines the dataset into batches, 32 images per batch approximately, and enables shuffling if needed. So the output is going to be the total number of loaded images is displayed. So the total loaded images are 5. So data loader efficiently handles batching and pre-processing, preparing images for deep learning models. So transformations basically ensure all the images are resized and converted to tensors, which is a vital for compatibility with models like CLIP. So basically, this step organizes and pre-processes the images for embedding generation. So moving on to initializing the CLIP model. So CLIP stands for Contrastive Language Image Pre-training Model, which was initially developed by OpenAI. So coming to device setup, which determines whether to use a GPU, CUDA, or CPU, and CLIP model and processor loads the pre-trained CLIP with base patch 32 model and its processor from Hugging Face Transformers library. So coming to the model, CLIP is a powerful model that can generate embedding for both images and text. So coming to processing, which gonna handle pre-processing of images and ensure compatibility with the model. So in general, using GPU speeds up computation. So this step set up state-of-art model for generating meaningful embedding from images. So let's start generating image embeddings for images. So embeddings are high-dimensional vectors representing the features of each image. So coming to evaluation mode, sets the model to inference mode to save resources. So images are processed in batches. So passed through the clip processor and their embeddings are extracted using get image feature method. So embeddings are stored in list and later combined into NumPy array embeddings. So the shape of the embedding is 5, 12. Therefore, 5 images each represented by 512 dimensional vector. So using PyTorch ability, therefore torch.nograd saves no grade saves memory during inference. So embedding capture essential visual features of images, enabling downstream tasks like clustering. So these steps convert images into numerical representation suitable for machine learning models. So we're going to perform PCA on embeddings. Therefore, the principal component analysis reduces the dimensionality of embeddings. So PCA reduces dimensions to a maximum of min of n samples, comma and features minus 1, ensuring no loss of critical information. So embeddings are transformed into lower dimensional space while retaining maximum variance. So calculating the cumulative variance explained by each step. Embeddings are reduced to 4 dimensions. A plot of cumulative explains variance shows how much information each component retains. So basically dimensionality reduction simplifies data for visualization and clustering. So coming to variance retention ensures that the most critical information from the original embedding is preserved. So moving on to clustering the embedding with k-means. So cluster setup, so which specifies the number of clusters defined here. The n clusters is 3 and a random seed for reproducibility. So k-means assigns each embedding to one of the clusters for fit and predict. So each embedding receives a cluster label indicating its groups. Clustering identifies patterns and groups similar images based on their embedding. K-means work efficiently on reduced dimensionality embedding from PCA. So basically these steps groups images into meaningful clusters for further analysis. So visualizing using UMAP. UMAP reduces embedding to two dimensions for visualization. So UMAP parameters are which are defines neighborhood size. So here in case neighborhood size is 15 and minimum distance between points which is zero point 0.1. So UMAP projects PCA reduce embeddings into a 2D space. So the clusters are plotted with each cluster assigned a unique color. And moving on to displaying sample images. For each cluster, it retrieves image paths corresponding to cluster labels. Display images in a grid, labeling them by their cluster. It ensures clusters are meaningful by examining their content and also helps to confirm visually similar images are grouped together. So cluster counts the number of images per cluster and barcode visualizes the cluster sizes. And that's all about the video. Thank you.